Yeah, recording has been started all. So,
Okay. Dear friends, hearty welcome to the second day of the 7-day crash course on focusing on TIFR GS 2025. We have our resource person, Mr. Lalit, with us. Uh, as you know, he is a research scholar at IISc Bangalore. So I welcome everyone to this event and wish you all a fruitful academic time ahead. Welcome, Lalit.
yeah. Hello. So, am I audible?
Yeah, yes.
So, can anyone of you confirm that you can listen me?
Yes, sir.
Yeah. Okay. So, yeah. So, without wasting any of time, we should start. I think. Okay. Let me present my screen. So, yesterday we solved problems from 24 and 23. As I said that you can check the 2024 playlist in YouTube channel. So I would be discussing today the problems from 2023. Most of the problems are from 2023 exam, and I would also be posing questions as yesterday. So many of you after the class text me and telegram and said that yeah, you like that very much. Okay, when I gave you problems to think. So yeah, okay. So let me join from another device. It will take me 1 minute. Okay. So please confirm if you can see the screen. Any one of you? Okay. So once you see the screen, let me know. Okay, I'm presenting now. Yeah. So uh, could you please confirm someone? Yeah. Okay. You can see the screen. Okay. So okay, let's start with this question. This is the question from Uniform Content T. Okay, so most okay, but I would definitely be asking you questions from algebra and linear algebra. There are only three parts from which the questions are asked in the TFR exam: linear algebra, abstract algebra, and real analysis. Okay, so this question is a true false question. What it says, let's see. Let alpha be a positive real number. So it's a positive real number, and f is a function from G which satisfy this inequality. Okay, so all x, y in 0, 1, then f can be extended to a continuous function from close interval 0, 1 to r. So when can you extend a function? Okay, let's think about it. Suppose you have a function f, right? F from 0, 1 to r, you can extend the function from 0 to see that the limit at endpoint exists or not. Either you directly verify from this inequality, but one thing you can use. So we can extend a function f to the closed interval 0, 1 from open interval 0, 1, a continuous function if and only if it's uniformly continuous. That means that a function will be uniformly continuous if and only if the limit at endpoints exist. Okay, so it's easy to see that it's a uniform. So here I am using the result, not writing it here. That it here. Okay, so result of function, it's continuous. Okay, so a continuous yes function f 0, 1 to r can be extended to a continuous function from closed interval 0, 1 to r if and only if it is UC. On UC means uniformly continuous. Okay, so on open interval 0, 1. Okay, so you you know all the definition of uniformly continuous function, right? So for each given epsilon which is greater than zero, we this difference there exists a del such that what happens whenever there the points x y satisfy this any points of the domain, okay, we get this, right? So what we want here, we want here, right, how can you see that this is uniformly continuous? Can you do this? I mean, you have given this, right? So you want this to be less than epsilon, right? Suppose the epsilon is given and fixed. So x minus y, the alpha power of modulus x minus y. So you want to make it less than epsilon. Okay, if you will make it less than epsilon, then this will become less than epsilon, right? When is this? When this quantity is less than epsilon? If mod of x minus y is less than this, and this is a positive number, right? We can take it as a del, right? So we will write that fx minus fy is less than x minus y alpha. This is less than epsilon if mod of x minus y is less than this number, and this is positive because epsilon is positive and this is a positive number, right? And we want that. So our function f becomes uniformly continuous, right? So it means f is uc on open 0 1 open 0 1. This implies that f can be extended to a continuous function continuous function on closed interval 0 1. Okay, so this is how we solve this question. But still, without using this, you can show that the limited endpoints exist. Okay, so suppose you want to, okay, so it's your homework that can you show that the limited endpoints exist at 0 and 1? Okay, so once it exists, then f can be extended, right? So I just want here that you know this. This might be useful. This definitely be useful. Okay. So now a question for you is that, right? So suppose you have a given function q, right? Suppose you have a continuous function from q to r. Can you always extend it? Can you always extend it to r continuously? Okay. Extend continuous to a function from r. So what is your answer? Can you extend it? Suppose you have a given function which is continuous on Q. So can you always extend to that function to R? So raise your hand if you know the answer. Okay. Okay, so one of you raised the hand. So what is your answer, Manoj?
May not be extended because the
Mhm.
supremum and infimum may
Because
not be lie in Q.
yeah, right, right. Give me an example. Why cannot be extended?
Because supremum and infimum of Q may not be lies in Q.
Supremum of Q. Supremum does not exist, right? So how do
No,
you use that to
for
define a function? Hmm.
any
Okay.
set,
So how do you
let the
use?
set is 0, 1, open interval. So
Okay,
its
so
supremum and infimum.
right, supremum in R, right? Okay. So, but how can be used to define a function? Okay, so someone, how can you tell? Yeah, please. So, yeah, Kirtana. Kirtana. So you can tell. Okay, so anyone, can you give? Oh, by the way, I have given you the hint, right? How can you define a function? Okay, so uh, yeah, let me know. You should answer this question, right?
Sir, 1 upon 1 minus 1 upon x minus any irrational number.
Right, 1 upon x minus any irrational number, right. So this cannot be extended to a continuous function because the limited root 2 does not exist. But, so now suppose I say that you have a function f from q to r and that can be extended to r uniquely. Sorry, not uniquely. So question is that suppose you have a given function from q to r. Now suppose that can be extended. Okay. So suppose that can be extended, okay, to a continuous function. Dot, dot, dot. So what do you think? How many extensions are there? How many extensions are there? Can it be infinitely many extensions? Okay, so you can think about it. There is another question, okay? So suppose if
Sir, only one because of density of Q.
yeah, only one, right? So, because of the density, right? So others can think it. Okay, good. So now the another from uniform continuity. Uniform continuity is very important topic. Okay, in all the exams, NBHM, TIFR, CSIR net, GATE, you will see the questions from uniform continuity. Okay, so there are some special, special result. There are few result which helps you to determine whether or not a function is uniformly continuous. Okay. So one of the result I will let you know here, and that's very important. So see, this question is also from TIFR 2023 and of true or false. Okay. So suppose f and g are to are continuous functions. You have two continuous functions. It's given. Okay. Such that f square plus g square is a uniformly continuous function. There is no comment about the uniform continuity of f and g. So what has been asked here? Then at least one of the two functions f and g is uniformly continuous. At least one of them should be uniformly continuous. So let me solve it. So see what suppose you want to counter it. Okay, so how do you think? Okay, so first try to think about two functions. Okay, first try to think about two functions such that their sum becomes some well-known uniformly continuous function. Okay, so if that can be done. So think about two functions, two continuous functions. When you square them and add them, and you get a constant, and then immediately something comes to your mind, right? So that must be sine x and cos x, right? So I'm not saying that they are not uniformly continuous. Just think first. Okay, but what do we want? We are searching for the where there they satisfy this, that this becomes uniformly continuous, but neither f is uniformly continuous nor g. How? So we try to make some adjustment, okay, so that these functions becomes uniformly continuous after modifying. So how do I modify this? See, I define fx equal to sine e to the power x and gx equal to cos e to the power x, right? So you see here f square plus g square equal to 1, right? Everyone can see it? F square plus g square equal to 1. But neither of f or g is uniformly continuous. But how do you know that? Uniformly continuous on R. But how do we know that? How do we say that they are not uniformly continuous? See, okay, so there is a I mean, if and only if condition. Okay, I'm going to write it here. That will be really helpful for proving some function is uniformly continuous, in determining that some function is not uniformly continuous. Rather, you use that result to determine and to prove some a lot of times that function is not uniformly continuous. What is that? So suppose f is a uniformly continuous function from, sorry, just a continuous function from R to R, then f is UC on R if and only if for any pair of given sequences, given pair of sequences xn and yn satisfying fxn minus this sequence goes to 0. Okay, so sorry, so this is not satisfying xn, this sequence goes to 0. We have, what will we have? This function must go to 0. Sorry, this sequence must go to 0. Okay, so this is a if and only if condition. Okay, suppose that you this satisfies for any pair of sequences. Okay, this then f will be UC. If f is UC, then this will be satisfied. Okay, so what if we want to show that some function f is not uniformly continuous, then what will we do? So we try to find a pair of sequences xn and yn such that their different sequence, that is the sequence defined by this, right? Mod of xn minus yn goes to 0. Yeah, mod of xn minus yn goes to 0, but this sequence does not go to 0, right? This is enough to say that f is not uniformly continuous, right? From this result. Okay, so now we have this function, right? Sine e to the power x, and similarly you can prove that cos e to the power x is not uniformly continuous. Okay, how I'm going to construct example C. Okay, so what I want here, so I will first try to get here something like this, n plus 1 pi by 2, n plus 1 pi by 2, okay, minus sine n pi by 2. Because that sequence will then does not convergent. Okay, it will be, you know, there will be in some points will be more than two, there will be 2 or 3 points which will be repeating, so the function will not be, this will not go to 0. Okay, so I try to do that. So how do I make the sequences? So I will define xn equal to log n plus 1 pi by 2 and yn equal to log n pi by 2. So where this sequence goes, so this is your work, do it and let me know where this sequence converges. If converges, their difference must converge. Okay, so let me know where this converges. Yeah, it's easy, right? So
This goes to 0.
Difference is this, right? Yes or no? Difference is this, right? The pi by 2 will be cancelled. Okay, and this goes to 0. How? Because just take n common and then see that n tends to infinity. Okay, let me write it here. Okay, so log 1 plus 1 by n. Now you can see that it goes to 0, right? As n tends to infinity, then log this sequence tends to log 1, and log 1 is 0. Okay, so now, but this difference fxn minus gx, sorry, minus Fyn, you see that this comes out to be sine. So you can put the values and see that this will be n minus 1 pi by 2. Okay. Minus sine n pi by 2. Right? So what do you think about this sequence? Does this go to 0? The functional sequence. What do you think? Okay, Deepa Sahu, yeah, let me know. What do you think about this sequence? So is it convergent or not convergent? So think about it. Right. Okay, so how do you see quickly that this is not a convergent sequence? This does not go to 0. So you don't want it to, it doesn't matter if it is convergent. What do we want? We want that this does not converge to 0. That's what we want. Okay. So let me show you that this does not go to 0. So how do you show that? Okay. So see, if you pick n equal to say 2k, right? So n is
It
given.
tends to 1.
No, yeah, it might tends to 1, but let me show you that it does not go to 0. Okay. So see, if you take n is even number, then what this comes out to be 2k plus 1 pi by 2, and this goes to, right, because n is even, that this will become k pi, and that is 0, right? So you have this subsequence. The subsequence of even terms is this. So do you think that this is convergent? When k will
Our
vary over
function is
natural numbers?
sine e power x, right?
Huh?
Our function is sine e power x, right?
Yeah, but yeah, right. Our function is sine e to the power x. But what do you have exn? So see, okay. So this is just a calculation. Then
Yeah,
xn,
then
we
f
have
of
this.
xn will be n plus 1 pi by 2 only.
Yeah, right.
Yes. Oh, okay,
So
okay.
because, okay, let me show you. Okay, from here, see. When log comes here, I mean, take e on both sides. E to the power xn is n plus 1 pi by 2, right? From here you can see it. Is it fine?
Ah, yeah.
Yeah, okay. So see, so this is not convergent, right? This goes to 1. Okay. So sum of its subsequence goes to 1. It clearly means that it does not converge to 0. That's what we want. That's why this function is not uniformly continuous. And let me tell you, one of the TFR questions in previous year asked also in a true false section that whether or not this function is uniformly continuous. Okay, so we have done two things in one question. Right. So in this way, this function is not uniformly continuous. And one of the, similarly, you can prove that this function is not uniformly continuous. Okay. By similar reasoning. Okay. So in this way, we see that this is a false statement. We will square them and add them, we get a continuous function, but none of the f and g is a continuous function. Okay, so now is a question for you, that suppose you have two functions f and g such that f operation g is uniformly continuous. So what is your comment about the continuity of f and g? So that might be some easy question, right? Okay, but think about it. Suppose you have two functions on R and nothing is given. They are just functions, and you get that f operation g is uniformly continuous function. So what can you comment about the uniform continuity of f and g, continuity of f and g?
Nothing can be said.
Nothing can be said. Okay, so they can be continuous, they can be. So what is your counter example? Okay, so how do you counter
So
it?
take G at rational 1 and irrational minus 1 or
Okay.
0.
Okay.
And similarly, take f at rational minus 1
Right.
and g at rational.
Right. Good. Okay. So there is another question that, yeah. So the counter example is that they can even be discontinuous everywhere. Okay. Both f and g are same. Take them. X belongs to Q complement and Q. Okay. So this is your counter example. So now my question is that suppose f r to r both are uniformly continuous function. Okay. So what is the comment about the uniform continuity of G operation F? Raise your hand if you know the answer. Okay, then I will ask.
Sin e to the power x.
So yeah, you're right. Someone said something. Okay, is the composition of uniformly continuous functions is uniformly continuous?
No.
Yes or no? What do you think? Try to guess it. Okay, so only 3 hand raised. Okay. You think about it. You must think, right? Don't think that we cannot create the example or we cannot see it. Is it easy? Just think like that. Okay, so if you are constructing counter examples, then you will not be able to construct, okay? Because this is true statement that G operation F must be uniformly continuous. But can you see why? Can you see why? Okay, that kind of questions can be asked to you in your interview if you qualify the TIFR exam. Then something from uniform continuity can be asked. So, so we use this thing, okay? So I have told you this result, right? And I said that this is very important result. Okay, let's see. So suppose xn and yn be two sequences satisfying this, right? Okay, be any two given sequences satisfying this. Then by the uniform continuity, of f and g, sorry, f, we have this sequence fxn and fyn are sequences satisfying this, right? Because f is given to be uniformly continuous. Then we have this. Now we have two sequences fxn and fyn in R. They satisfy this thing, right? Their difference sequence goes to 0, right? So now in place of xn and yn, we have fxn and fyn. They satisfy the same thing. Then by uniform continuity of G, we have G fxn, G of fyn, okay? It goes to 0. That is same thing, G operation fxn and G operation fyn. So for any two sequences xn and yn satisfying mod of xn minus yn tends to 0, we have proved that the composed function, the G operation F also satisfies this, right? So by the previous result what I told that the composition is uniformly continuous, okay? This can be used to determine, suppose you have given two uniformly continuous functions like that. Suppose there is a question that is this function is uniformly continuous on R positive, right? Suppose this is just a statement that the sine root x is a uniformly continuous function, then you immediately know it because this is just composition of two uniformly continuous functions on R. Okay, so now there is something from uniform continuity. So last question from okay, uniform continuity. So right. not last question. There might be 1-2 questions from my side. So root x is UC on R. Okay. How do you prove this? This is a this is uniformly continuous function. Okay, see. So there is another result to determine
This
whether a
function is
function.
not defined on R.
Oh, sorry. I want to say R positive. Thank you so much. So so how do you prove this? That see, if some function is yes,
Can we apply Lipschitz condition about it?
yeah, very good. Lipschitz condition. So how do you apply that? Would apply
It's not satisfy root x.
right,
Yeah.
but root x is not Lipschitz on R positive, right?
Yes, yes.
But
Yeah.
it's a Lipschitz on, but yeah, right. You can do that. Where? So good. Fx minus fy is less than equal to m times root x minus y. Okay. So on what interval? Is it true or not? What I have written here.
Yes, sir.
Is it true? Does this satisfy this? So what is m? What should be m?
Aim always
What should be?
greater than
What is the value of m then? Okay, think about it. Okay, so so see, and root x on this interval is UC or not? From the previous discussion, can you tell that this is UC on this interval?
You see. Yes, sir.
Okay, right. So what do we get? That this function is UC on this interval. Okay, let me close it. Okay, so right, and this is UC on this interval. So FHUC on this is true. Okay, 0 to infinity. But now there is a question for you that suppose you have a function f from R to R, fh when restricted to A is UC and f is when restricted to B is UC. So what do you think about the function? I mean, will it be uniformly continuous on the set A union B? Suppose f is uniformly continuous on A, f is uniformly continuous on B, then is it uniformly continuous on A union B?
Yes, sir, it is true.
Okay, so Deepa, what is your answer? You raised the hand, right? Okay, but I can't listen you. Okay, Anjita, what is your answer? Unmute yourself and say yes.
I think no, sir.
Okay, you think no. So can you give me an example? Yeah, you think right.
If f is like in A, I am defining as a constant function, and B, I am defining a constant function.
Right.
Then
Okay,
A.
so we do like this. Okay, if x belongs to Q complement, right? When you see f on Q, this is constant function, so uniformly continuous. When you look at f on Q complement, this is again a continuous function. Sorry, constant continuous function. So this is uniformly continuous in both Q and Q complement. But when you know, in their union, it is not even continuous, right? So that's not true. Now you have to let me know tomorrow. Then wait when it will be true, because I have used something like that here, right? That I have shown that root x is uniformly continuous on A and it is uniformly continuous on B, and then from here immediately use that f is UC in A union B. So when it will be, I mean, true. Here it is true, I say, okay? So it's your homework, decide about it. So now is some question that if F is close interval AB to R, suppose open interval AB, another question, okay? So close interval AB to R, UC. No, sorry, open AB, some finite interval, differentiable. Okay. It might be differentiable twice, only once, I will say here. So what do you think? If F has bounded derivative, say F is bounded derivative, F dash is bounded function. F dash is bounded function. So most of you know that F is UC, right? I know by using main value theorem. So most of you must know this, right? This is very important. If F dash is bounded, then F is UC. So now suppose that you have not given that F dash is bounded. You have given F double dash is bounded. Okay, so no comment about F. So what do you think about the uniform continuity of F? Yeah, so Sri Hari, do you want to say something? So you are unmuted. Okay. So suppose F double dash is bounded. Yeah, Anjita, let me know. Okay, Kirthana, you let me know.
Mind where I thought like let f dash be 2x, then f double dash will be 2. So in this case, my f double dash is bounded, but f dash is not bounded. So f
No,
doesn't
right. F dash, why it is not bounded? You said
because
that
it's
suppose F.
2x. Oh, okay. The domain is from A to B.
Yeah, domain, what I have. Right.
Okay.
So, okay, think about this problem. Okay, this is your homework.
Yes.
So answer is yes. Okay, this. So you have learned a good thing today, right? You already knew about that. If F dash is uniformly continuous, then F is uniformly continuous. But you today learned that if our F double dash is bounded, no, sorry, if F dash is bounded function, then F is uniformly continuous. But if F double dash is, bounded function, then also F is uniformly continuous. Now the question is that suppose that F 2025 suppose it is differentiable 2025 times, that F 2025 is bounded. So what do you think about the uniform continuity of F? Okay, see, let me tell you the answer. Okay, see. So you have given that F dash is bounded, right? So F dash is bounded. That means that this F dash is uniformly continuous on AB, right? Right? Because F double dash is the derivative of F dash, right? So F dash must be uniformly continuous. So F dash can be extended from closed interval AB to R. Extension continuously. Okay, extended continuously. Right? You can note it. Okay, I'm not writing everything. You can write that. So, right. So, but a function which is continuous on a closed interval is always bounded, right? So F dash is bounded on open AB. So, and you know that if F dash is bounded, then F is uniformly continuous. So in this way, if any of the derivative is, now you have to think, suppose that any of the derivative of function is given to be bounded, then can you say that f would be uniformly continuous. So this is your homework, do it. Okay, so let's move to the another question. Okay, so now just leave behind the uniform continuity and come to this question. There is a question from this, this is objective question, okay, of 2023. There is only one correct option. So you have a equal to this, right? Minus 1 by root 2, sorry, 1 by 2 and root 3 by 2. So you have this. So now read this question and try to answer. Okay, let me give you 1 minute. Read this question. Yours, try to do yourself. Okay, I don't expect you to answer. Just read it and try it. So how are you thinking? Sorry, give me a minute. Yeah. So okay. So can you could you note something about this A, matrix A? If yes, raise your hand. Something special. Okay. So see, first let me
matrix.
rotational matrix. Okay. So see, x1 is given to be a non-zero fixed vector, okay, of R square, and inductively define the sequence. This is sequence in R square. Okay. So ax1, a square x1, a cube x1, dot 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 some. Okay. Can you see it? That our sequence xn is this, right? So try to see what is your x2, then see what is your x3. Then you will find that the sequence would look like this. Okay. So we have this sequence. Now here something to note that A is a this kind of matrix, cos theta, sin theta, and minus sin theta and cos theta, right? And what is the value of theta? You know that. What is the value of theta?
30.
5/6.
You should tell it. Yeah.
5/6.
5/6. Okay. So you have already seen this matrix. I'm sure you have seen this, right? So a to the power n is what? A to the power n?
And
A to the
goes
power
inside the
Sin and theta.
okay, cos n
Cos
theta.
n theta. Sin n theta.
Right. So our an is cos n theta, sin n theta, minus sin n theta, cos n theta. And from here, can you find order of this matrix? Order. I mean, when a to the power n becomes I.
12.
12.
12. Okay. So it doesn't matter whether or not 12 is least here, but so is 12 least?
So 6 is also there.
Okay, 6 will also work. Right? What do you think? When you give the power 6, what happens? Cos pi, sin pi, but cos pi is minus 1, right?
Yes, I.
Right. So I think 12 is least. Okay. So when you give, I mean, when you have a to the power 12 equal to this identity. So this sequence a square, right? A to the power n looks like this. I'm just talking about a to the power n, right? This is repeated cyclically. Yes or no? Do you understand this? Yeah, okay, good. So now what happens to this sequence? Okay, this sequence xn comes out to be, I did not read the options. Okay, they are asking about the convergence. That's why I'm finding this. So we have got this sequence looks like this. AX11, then again 2 dot dot dot. So now you have everything, right? So what do you think about the convergence of this sequence? You have a sequence, right? X1 is a non-zero vector. Okay, so AX1, AX2 need not be equal. Okay, you can pick some value of x1 and see it, right? So you have a sequence, say in real numbers, say you have a sequence like this. So what do you say about the convergence of this sequence? Xn. You say that this is oscillating sequence. So what do you think about the convergence of this sequence now?
It
This
does
is
not
not convergent
converge.
because it has more than one
It is
limit point.
right. It need not converge. So one is not true, right? A is not correct. So cut it. Xn is not, and the C is also not true, right? It says that Xn is convergent and has limit 0. Because in the exam, something you can do when you read options first, okay, read option, then cut it. This C cannot be true. Why this cannot be true? Because if C is true, then our A is also true. Because C says that C is correct means that X and it's also this say about the norm. Yeah. Oh, it is say about the norm. Okay, sorry. So, but sometimes it is given, say, suppose that if this were that like xn equal to 0, then you can apply that. Okay. Sometimes this kind of trick comes into play in exam. That might be helpful sometimes. Okay, I have seen it a lot of times to apply this kind of trick in Part B questions in CSR net and in GATE, in TIFR. So try to do that also if you find something like that. So, okay, so these two are not correct and this is also not correct, but why B is correct? Can you see? Xn is not a convergent sequence, but it has a convergent subsequence. Why? Because this is a bounded sequence. Okay, and by Bolzano-Weierstrass theorem, it has a convergent subsequence. Bolzano-Weierstrass theorem, Xn has a convergent subsequence. Okay. This Bolzano-Weierstrass theorem holds in Rn, okay? R square, R cube, anywhere. If you have a bounded sequence, then it must have a convergent subsequence. So in this way, you can solve this question in exam very easily. Okay. So what I have told you here, this is no matter if your A might be something different. It might be any matrix of this kind. Then the same thing will happen. Okay. So that's why I let it know like this. So yeah. So now let's go to the next question. Yeah, this is one of the question from TFR 2024. Yeah.
In this question, when we had to find the convergent subsequence, could we consider all the AX? Because after 12, it is looping back.
Yeah.
So
Right,
all the
right. We
AX
don't need to.
actually-
Yes, yes. Right, right. But yes, that's good. You can just take this sequence. Okay. AX1, AX1, AX1 subsequence. Right. I mean, you don't need by Bolzano-Weierstrass theorem here, but you have learned that also. Okay, suppose somehow you found that this is a bounded sequence, then you can apply, but you don't need it here. Okay, you can just take this sequence. Yeah, because everything is clear, right? There's this like that. Okay, first one term, then whenever you get AX1, then again you get AXN somewhere like that. AX1, right? Okay, good. That's good to note. Yeah. So do we move to next question? Yeah. So this question, what this says, this is also a question from TFR 2023. I will ask some interesting questions after this. Okay. So once you solve this question, so what this say, the number of elements of finite order in this group. Okay. So I think let me denote it by this. Okay. H. First says is 1, second says they're finite but not 1. 1 is always there, okay? So countably infinite, only countably many elements has finite order. The last one says that uncountably infinite, uncountable many elements are there, so that they have infinite order. Okay, so how do we solve this question? Okay, we want to know that whether or not this group has odd elements of finite order. Okay, pick a arbitrary element A. Okay, so we would like to see that this is an arbitrary element. I have taken an arbitrary element. So we want to see that when a to the power n equal to I. So what type of elements will satisfy for some n? Okay. So here something comes into play. Okay. So if you will directly take some element and apply, try to find a square, a cube, then you will get into trouble. Okay. It will be calculative. Okay. So not easy to decide. So what do you here? You know, write this matrix like this. Okay, where n is what? I will let you know. So I is identity matrix of order 3, and use this. You can use this in a lot of questions. Okay, not only here. So see, n is 0, 0. So do you know why I have written here n? Because the second matrix, the latter matrix, is nilpotent, right? You can see it, right? It's nilpotent matrix. Okay, so now it's easy to find the power n of a. How? See, so a to the power n equal to I plus n to the power n. Okay, so by binomial theorem, and observe that, note that, okay, n cube equal to 0. Verify it. Okay, if you have a nilpotent matrix, how can you see this? You don't need to verify it. It's all eigenvalues are 0, right? Right? It's all eigenvalue 0. The latter matrix has all the eigenvalue 0. So its characteristic polynomial is x cube equal to 0. And by Cayley-Hamilton theorem, it will satisfy the characteristic polynomial. So no need to do calculation. Just apply results. Right? So is it okay that n cube equal to 0? So at least you can react, so that I'm sure that you are listening to me. Okay. So you have option of reaction there. So sometimes it feels that my voice is not clear to audience, something like that. But when you react, then it make me sure that yeah, it's okay, everything's fine. So see, if you expand it by binomial theorem, why can we apply here binomial theorem? Any of you want to?
Because both are commutative.
Yeah, because they are commutative. Okay, that's why we are. So I have written just this. NC3, n cube is 0, so n4 is 0. So I don't need to write the further elements because they all are 0, right? So NC1 is, and just write it n. And the NC2 is also non-zero number A. Okay, note that. So write it A. Okay, so A to the power n is this. So we want this to be I, right? We want, right? We want a to the power n to be I. So now can you yourself do the calculation and let me know when it can be equal to I. So do the calculations now. It's your work. So no one could
Sir?
Yeah, please. Yes.
Here n square will also be 0, right?
Why n square would be 0? If you put
Because
a b c equal to, okay, just put a b c equal to 1 1 1. Then in this case, n square is just the matrix which has entry, 1 at the yes, rightmost top corner, right? And others are 0, I think, isn't it? If you take ABC equal to 1 1 1,
okay, so I'll verify.
check it. Then what do you get? N square equal to some non-zero matrix, right? Only one non-zero entry in the top rightmost corner. I mean, A13 is non-zero. 13 entry is non-zero, that is equal to 1, and other entries are 0. So n square need not be 0. Okay. Am I right?
Yeah, it's n square is not
Yes,
0.
sir. It's
Right.
AAC.
So you want it to be equal to I, right? So then in that case, an square must be equal to 0, right? Yes or no? Here, see, n and a both are non-zero. Okay, so this polynomial annihilates n, annihilates n, your matrix n, right? It annihilates. So see, we will take here a not equal to identity. Okay, because we know that order of identity is 1. We are searching for the order of non-identity element. So minimal polynomial of n can be, what is the minimal polynomial of n? Possibilities. Minimal polynomial of n, mnx. It will divide characteristic polynomial, right? Either x and x square and x cube. What I said, that you will not take a equal to identity, so that the minimal polynomial cannot be x. Okay. Can you see that the minimal polynomial is x square and x cube? So you have a polynomial which is annihilating n. So minimal polynomial must divide this, right? X cube or x square. But is this true? What do you think? Is this true? No, right? It is not true, right? Yeah, so not, it is not possible. Both a and n are non-zero. Okay, keep that in mind. Not possible. So what do we get? We get that if a is not equal to identity, then this thing can never be 0, no matter what the value of n. Okay. So can you see the red pen on the screen?
No, sir.
Yeah. Okay. So what do I get? That a to the power n is equal to this I plus nn plus an square, right? So I get that this quantity is not going to be 0, because if this quantity is 0, then we get some contradiction. So no matter what value of n you have, you are finding that a to the power n is not equal to identity. So any non-identity element has order infinite. Is it clear to everyone? So any non-identity element has infinite order, right? Yeah. So the answer is only first one. Now, a question for you is that this is very interesting question. Okay, it is called Heisenberg group. If you want to note its name, you can note. It is called Heisenberg group, and you can read about it in Wikipedia also, some interesting properties of it. So let me ask you a question. Then I will ask you a question again at the last of this class that will dependent on this question. Okay, that would be very interesting question about a group of 2025 order, but at the end of the class. But now I'm asking you that suppose that you have a group H, okay, like this, H equal to 1 1 1 0 0 and A B C. Okay, so here ABC, comes from ZP. P is a fixed prime. Okay, fixed prime. So what is the cardinality of this group in this case? What is the cardinality? Count it. It's very easy. Just let me know.
P cube.
P cube.
P cube.
Right, P cube. So can you find the order of each non-identity element here? Okay, find it then. So what is the order of each non-identity element? So if you know already the answer, you can raise your hand. Okay, no need to solve if you know the answer. Everyone, anyone, okay? So reaction will not do. You have to raise your hand if you know the answer, because I don't know who I have reacted in this case, right? Reaction is not enough condition mathematically. Okay, so okay, okay. Okay, only one student has raised the hand. What about others? What is the, just do that, do the same thing, and you will immediately find the order. That's why I have told that thing, right? Do the same thing what we did in the last question and find the order of each non-identity element. Okay, so Pallavi, bolo, what should be the answer?
So if P greater equal to 3, then it is P. Means order
Okay,
of
very
it.
good. What about P equal to 2?
Then sir, this group is isomorphic to D4. So order will be accordingly.
Right, very good. Okay, good. So see, you can do in the same way. Okay, see, when you suppose you have a non-zero matrix, say A, okay, then do the same thing, write it I plus N and give the power P. So what can be the order? First, you should have something in mind, right? What is the possibilities of order? The possibilities of order is that the order can be p square of an element and p cube, right? Because the order of element divides the order of the group. Element is p square and p cube, right? So just check that what happens if we find the power p of a, then this comes out to be p, but by binomial theorem we get that this is pc1 you know, right? Pn and pn square, right? Is it correct? Sorry, no, not Pn square, PC2 n square. Okay, right? Is it correct? Do you think? Yes or no? PC1 is P. So what do you think about now? P times anything is 0 in ZP. Yes or no? So now let me know what this comes out to be. Okay, so Pallavi, how do you say that when P equal to 2, this will be identity? If you have P equal to 2.
If P, then sir, 2C2 will be 1. So there will be one n square term.
Okay,
So,
good. So right, very good. So PC2. So see, if your P is not equal to 2, right? P is greater than 2, then this and this PC2. Both are divisible by P, right? Yes or no? Check that. Right. So this comes out to be I. But when P equal to 2, then you get something like this also. Right? So in that case, there are elements of order 4. So, but in case of 2, you can check that this is very easy. In case of 2, 8 is of order 8, and order 8 group is either isomorphic to D4 or isomorphic to Q4. Right? So just try to see that how many elements are there of order 2. Then you will find that there are more than 2 elements of order 2 in this group. When P equal to 2, then that must be isomorphic to D4. Okay, so here you get an interesting example of a group. H is a group non-abelian. Okay, non-abelian, non-abelian, and what did you get? Each non-identity element has order P. That will be very helpful for you. Okay, so a group of order P square is abelian, a group of order P is abelian, but a group of order P cube need not be, a group of order P cube need not be abelian. Okay, we might have non-abelian groups of order P cube, and there is an example. Okay, so let's move to the next question, and this is very interesting question, by the way. So you might feel that you cannot solve it, really. So someone can feel that, oh, this might be very tough question, might be very difficult question. There is something which I have not read in the syllabus, but you don't even need to read a single line from the syllabus to solve this question, believe me. If you have uh, you have done your 12th, then you can solve it. Any one student who is just understand the number theory, addition, something like that, can solve it. Addition, product, nothing is needed. Just try to think about this question once. Okay, so I will give you 2 minutes. I want you to think about it. And believe me, this is very easy question. But most of the students, what I found last time, did not touch this question. And a lot of students ask me also that how to solve this. This might feel difficult. This is, I mean, they find it to be difficult, but this is not difficult. Try it. Question says, okay, then you will try. This question says, because some of you might not understand it, the language quickly, the value of the maximum will attain because there are only finitely many elements in the set. So whenever you take some partition of 100, okay, this basically says, suppose you have a partition of 100. Okay, partition means, I think partition means you just, divide 100, sum of the elements, sum of the integers less than and equal to 100. Okay, that's is called a partition. Its name justify it, right? Partition. So you consider the product of the partitions, terms of the all the terms which are appearing in the partition. So what can be the maximum number you can get? This is very interesting question. So what it says that consider all the partition of 100 and take all the products. If you have a partition, then take the product appearing in take the product of terms appearing in that partition, and in this way do for all the partition, and what is the maximum value you can get? That this question says. Okay, now try to solve it. So everyone got the meaning of the question, right? Yeah. Okay, try it. Is 2 to the power 50 is maximum? Is 2? Okay, by the way, this is, I think, here, it is not written correctly. I think here it is, because otherwise you will quickly, it is this, right? It is typo here. Okay, sorry. Because otherwise anyone will realize that this is not true. Okay, so they may question in such a way that you cannot easily realize that this cannot be true. So no one could do it. Try once again.
Option A is correct.
Okay, good. Someone said why A is correct. Why? Obviously, A is correct.
Because it is greater than 2 to the power 50.
Oh, but how do you quickly find that it's greater than 2 to the power 50? Okay. Is there some easy way to see that it's greater than 2 to the power 50?
I just try this in this way. That is 4
Right,
into
but
3 to the power 32 and 4 into 2 to the power 48.
2 to the
And,
power 48.
and I have partitioned this in this way, and I find that
Okay.
3q
Okay, so you find
is
that.
greater
So
than
in
2
this
to the
way, you
power 4.
find, okay, right? If you did like that, in this way, you found that the B cannot be correct, right? But it doesn't say that A would be correct, right? So what your work says
But,
that B
but
cannot be correct.
in any way we partition this, then we get a power of 2 more than, okay, in A,
Okay, why C
2
cannot be
square
correct?
into, because A is greater than C.
Okay, did you do something same thing to determine that A? Okay, but why A is correct? Because D can also be correct. None of the remaining three options, because maximum can be something else.
But if we partition 100 in any other way, then we get a power of 2, which is more than 2 to the power, which is more than 2 to the power 2. That is 2 to the power A, where A is greater than 2.
Okay,
So,
you may be right. Okay, I did not understand, but you might be correct. Okay, so right. So this right, it is correct. Okay. So see, so say you have a partition. Okay. Say you have a partition that this thing is maximum. Say this is maximum of the set S. Say this set is S. Okay, name it S. So if it is maximum, so so see, no x1, I mean x1, x2, none of them can be 5. 5, 6, 7, they cannot appear in this partition. Why? For the moment, assume that there is some term 5. Okay. To understand this, for the simplicity, assume that you have 5. So the product is 5x2 dot 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 xk, right? But then immediately I have another partition which gives the, I mean, corresponding product is greater than that. Let me show you how. So I can break this 5 like that. Okay, so its product is 3 into 2 into x2 dot 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 xk. So you see, right, that this is 6 times of this and this one is 5 times of this, right? So it means whenever there is some term which is greater than 4 in a partition, then I can immediately find another partition whose the corresponding product is greater than the corresponding product of this former. Okay, of this one, right? Do you understand this? And this can be done for any y. Okay, it can be done for 6. You can just break y in y and y minus 2, something like that. I mean, y minus 2 and 2. Okay, if you have like that, you can do that. Okay, so no term can be 5. Okay, and if some term is 4, right? Say some term, for simplicity, just say that some term is 4, then you can again break it in 2 plus 2 and get the same product, right? So yes or no? If some term is 4, then we can find another partition which gives the same product. Just break 4 into plus 2. The product would be same. 2 into 2. So no need to consider those partition which have terms greater than 3. Yes or no?
yes, sir.
Right. Now only 2 and 3 can appear. Okay. 2 and 3 can be in the partition. So we are reduced to the case where only 2 and 3 will be in partition and the corresponding product will give you the maximum. So now can you think that how many 2 will be there? and applying the same thing, and how many 3 will be there? So this might be the correct. Can all 3 be there? No, all 3 cannot be there. Okay, see, suppose, but by all 3s you cannot cover this 100, right? Because 100 is not the multiple of 3. So not all 3 would be there. 1, 2 is there. Then again the same problem is there. You cannot cover 98 by all the 3s. So at least 2, 3 is there. Yes or no? Do you understand what I'm saying? That two must be there, right? Otherwise, you cannot get all the 3 and plus 2 is equal to 100. All the 3 is equal to 100. So at least 2 is there. So now what should be the remaining terms? This would be 3, or we can supply more 2s. Okay. So you can think about it. Okay. So my claim is that now see that now if there are more 2s, okay, if there are more 2s, yeah, please.
So we cannot have more than 3 2s.
More than 3 2s. Why? Good.
Because 2 plus 2 plus 2 we get 6.
Right, and
Which
that
is
can be
also
breaking
3
3
plus
plus 3, right?
Yes.
That can be written 3 plus 3, right? Very good. So we cannot have 3 2s. Okay, because whenever you have 3 2s here, then you can write it 3 plus 3 and get a partition whose corresponding product is greater than the corresponding product of this partition. So exactly answer is 2 plus 2 and the remaining will be 3. So now do you think that you need to read the syllabus of TIFR to solve this problem? Some of you said yesterday, so I have not covered full of the syllabus, but there are such kind of problems there where you don't need, I mean, you just need the basic. Okay. So there will be more questions. Okay. So if you have covered 50% of the syllabus, just try to solve questions there. Whatever you know from, if something you have read group theory, then if something is from group theory, then try to solve that. Okay. You have to do that for those which have not covered full of the syllabus. Okay. Right. So this is very one of the very interesting questions. So okay. So yeah, let me go to the next question. Okay. So let G is a group generated by 2 elements X and Y, each of order 2, then G is finite. So, and there will be subsequent questions. Yeah, there will be a very good subsequent question after this. In the exam, how do you think about it? Let me tell you. You have group G generated by 2 elements, okay, of order 2, then G is finite. Generated means, you know, right? Group generated by 1 element, group generated by 2 elements. Let me tell you in short. Then the G consists of all the finite products of powers of X and Y, okay? Right? Group generated by X and Y. Okay. So in case of generated by one element, in case some group is generated by one element, then we see that it looks like X to the power I, where I is some integer. So, but when group is generated by 2 element, then it is the collection of all the products of powers of X and Y. Okay. All finite products, obviously. So you have 2 elements. G is something like this, X and Y, and X and Y satisfies this, right? Need G to be finite? No, because in the case of abelian, will it be finite? Suppose that G is abelian. If it is given that G is abelian, what do you think about G then?
And it is finite.
Right. If G is abelian, then it must be finite. Okay, so don't, because in this case, G is something like this. You can do that. So I and J belongs to, this pair belongs to Z cross Z. Okay. So because in that case, you have finitely many choices, right? For I and J. You can just put 1 and 0. Because after X to the power I would be equal to either X or X, either identity or X, right? If order is 2. If G is abelian, then it must be finite. But here comes the very good part, right? What happens if G is non-abelian? Then it might be infinite. Okay, so think about some non-abelian groups, infinite non-abelian groups. Then something comes to your mind, GL and R, right? From here, we will extract the example, right? It's not good to tell you just directly the solution, right? I should also let you know that how do you think about the examples. So how do you start? You start picking from some EG groups. So what you know is you pick abelian group, but that might not be possible. And you are keep on picking the abelian groups, but that would not work, right? Because you know that abelian groups will not work here. Okay, so once you see some non-abelian group, then think about some non-abelian group. The group must be infinite, right? So GLNR is a non-abelian group. So can we take some two-order element? So what is his idea? Our idea that we pick two elements of finite order and their product is of infinite order. Obviously, that can be, right? So see, I took two elements like this. Okay. So how do we construct these type of elements? You can just try to put 0 and 1, try to get something like that. Okay. So it's EG. So can you see that order of A is 1? So I mean order of A is 4. Yes or no? Order of A is 4 and order of A is B is 3 or 4. I mean they are finite just. Okay. You can check that. Their order is finite. Check. Oh, I want order to be 2, right? Order to be 2. So, right. So, okay, let me tell
So
you
I
this.
think
Yeah,
0,
yes.
1, 1, 0 and 0 to half 0 will work.
Okay, so 0, this one 0, 1, 1. 0, 1 must be there because I want the elements of order of 2, not of order greater than 2, right? But yeah, if this is of order 2, then I can take A square, right? That would have order 2. But I can, in some way, I can modify. Once I get this type of thing, that order of A something even and order of B something even, and I can modify to get the order of elements of order 2. Okay, so what B can be? Yeah, someone told. Please let me know what B can be.
0 to half 0.
0 to half 0. Yeah, very good. So both have order 2. You can check that. Okay. Right. But what is the order of AB? Find the product AB. What do you see? So here you see 1 by 2 and then you see here 0 and 0 and 2. It has it's I mean
Infinite.
infinite order, right? Do you see? AB to the power n is just power of the diagonal elements, right? Order of AB is infinite. So how this, I mean, there is some element, the group generated by AB is also inside G, right? And this is isomorphic to Z, a cyclic, infinite cyclic group. Or you can say just some infinite set is inside G. So G must be infinite. Okay, so yeah, in this way we solve this question. Okay, so now some question from finitely generated. Okay, finitely generated group. So let's find that whether or not this group, do you know this group? Direct sum of Z, right? What does this mean? It consists of sequences where each element from integer, but after some stage, all element would be 0, okay? The terms of the sequence can only finitely many can be non-zero. Okay, you can say in this way. So what do you think about this group? Is this group finitely generated? This is very good question. Okay, can be asked in interview, in exam, and most of time student let me know that this question was asked somewhere in interview. Okay, whenever the finitely generated thing come. Okay, so think about it. This is finitely generated. I mean, can only finitely many elements generate this? No. You learned something in above discussion, right? It is an infinite group. So can finitely many elements generate it? Okay, think about it at home. Okay, so let me know another question. First, I think I should ask this one. Okay, first. So can it be generated by finitely many elements? This group Z2, direct sum Z2, direct sum Z2. This is easier than this, the last one, right? Here each non-identity. Yes, yes.
No, sir, it cannot be generated by finite element.
Why?
Sir, actually, its generators must be means.
Okay, suppose it is generated by 3 elements, right? Then it will look like this. Okay, for to understand. But we have finitely many choices for I, J, and K, right?
Yes,
Because
sir.
each non-identity element has order 2, right? And okay, so decide about it. You can think about it at home. Okay, so now the first, I think, yeah. Okay, so I have less time, I think. So only 4 minutes. Rather than solving these 2 questions, I will. But this was a question of NBHM. I really wanted to solve it. This is very interesting. You can try it at home tomorrow. But I would definitely be discussing it in some day in the within 7 days. Okay. So this is very good question. If you can solve it, try this. This is question of NBHM even. And I could not cover this question, but what I have referred you some videos yesterday, right? Some channel where you can check it. Okay. So, and yeah, these 2 questions I could not cover today. Tomorrow I will be discussing problems from the years from not from 2023, not from 2024, but from behind. Okay. So, yeah. So now some questions. So suppose G is a group of order 2025. Okay. Can it be non-abelian? Or always abelian? So if you want to know the factorization of this, should I tell you, or you can quickly realize that what is the factorization of this? It is square of some
E power
element.
4 into 5 square.
Right. Is it correct that it is square of 45?
Yes.
Okay. So you know that trick, right? How to find the square of some 2-digit number who ends with 5? You know that? Okay. If you don't know, you should know it. Okay. So yeah. Yeah. So must it be non-abelian? Sorry, must it be non-abelian? Must it be abelian? Or you can give some example which is non-abelian. Raise your hand if you know the answer. I would be happy if you will tell me. Then I will think that, yeah, you are listening. You have been listening me carefully throughout this lecture. Because I have told you something.
Just a non-abelian group.
Yeah, okay, okay. Well, you just have to raise your hand, okay? Raise your hand if you know the answer. I just want to see that how many of you could catch that thing, what I told just ago. Okay, you have a group, then how do you construct new groups? Taking product of the groups, cyclic groups, right? So try to do that.
I think this is always abelian.
Okay, why this is always abelian, by the way?
This is of the form P square is always abelian, and
Yeah.
P square into Q is here 5. So group of order 45 is always abelian.
45 is not prime, okay? P square, group of P square is always abelian. P square order is always abelian, not for any general element, group of order M square. So keep
Group
that
of
in mind.
order 45 is isomorphic to either Z45 or or Z9, oh sorry, Z9 cross Z5.
That would be
It is
Z45
always
again.
abelian.
But group of order 45, is it always cyclic? Don't you think so? Can you find, okay, but that would not help you to create, I mean, decide whether or not G can be non-abelian, by the way. By the way, let me tell you, the group of order 45 is always cyclic, okay? Yeah, that's true. No, I think it might not be, okay? Check it, because Z9 into, yeah, Z3 into Z15. Yeah, that must be. Because if you apply Silo theorem, you will get that. Okay, 1, 2, 3, 4, 5 student raise the hand. Okay, 6. I already know some of you, right? But how many of you just learned from the previous discussion that, yeah, there can be non-abelian group? Raise your hand, because I have told you something, right? Okay, so I would ask Arun, can you give me an example of a non-abelian group?
Yes, sir.
Yeah,
First
give
one is
me.
matrix group of order 2 by 2 in Z5 field.
Which group?
Sir, one upper triangular matrix with diagonal elements, so 1, and other one is Z5 from Z5.
But that would be group of order 5 cube. But 5 cube does not divides
Yes,
this.
sir, 2 by 2 matrix.
Okay,
If I
but
take
5, but that would be
square
abelian, right?
length direct sum Z 3 to the power 4. So if it abelian and non-abelian, direct sum is non-abelian.
Right. That is good. But what do you taking H? H
Yes,
is
sir.
of
Matrix
order.
group.
Huh?
Yes, sir. 2 by 2 order matrix with in Z5 field.
But
Upper
that would
triangular matrix.
be, that would be of order 5, right? Because we have
Yes,
only one. That would be of order 5. Okay, your idea is correct, but try to. Okay, Pallavi, tum batao. You tell.
So मैंने H cross Z3 cross Z5 square. H is Heisenberg group over Z5. Sorry, Z3.
Right. Okay, so Z25. Right. You just take Heisenberg group, right? What I have told you just ago, that there is a non-abelian group in which every element has order P, right? So just take here ABC, and ABC comes from Z3, and it's obviously a non-abelian group, okay, of order 3 cube. You have learned it, right? Just ago. Yeah, that's what you have to apply. There might exist a non-abelian group, okay? Because see, some of you, right, might feel that that must be abelian, because most of you could not answer. So it might be in the, because whenever you are given to appear for an exam in some specific year, then such kind of questions are there. I mean, a group of order 2025, a group of order 2024. You may see this in all the exams of the specific years. You will definitely find some question which has number relating to the same year. Okay, so yeah, obviously we can have a non-abelian group. Okay, so is this only okay, so now the question is that, is this only non-abelian group of order a non-abelian group of order 2025? This is your homework. Okay, can you find some other non-abelian groups which have order 2025, but this is not isomorphic to it? Okay, so some homework questions. So can you find the automorphism group of ZP cross ZP? So I wanted to ask you that, because I'm running short of time, so we are running over the time. So see, the automorphism group of abelian group can be non-abelian. Okay, so the homework is find the automorphism group of ZP cross ZP. P is a prime. So I think we should stop here, and I should say that please watch this question, and I will let you know this sometimes. Okay, so I should stop here.
Okay, thank you, Lalit, for today's session. Okay, dear participants, it's your time. You can ask any doubts, or if you wish, you can share your comments now.
Okay, anything you want to ask? Yeah, okay.
Sir, I have a doubt regarding your first question that you asked at the beginning of the class, that if f is a function from q to r, being a continuous function, how can we extend, I mean, why we can't extend f from continuously from r to r? You gave some example as well. I couldn't get that.
Right. So where is that question? Yeah, you cannot access. Suppose you extend it. Okay, suppose you get a function from r to r, right? But see, the limit at root 2 must exist, right? Because root 2 is irrational number, the limit should not exist. Because as you go, near to root 2, then you approaching infinity. See here. So it cannot be exist. It cannot exist, right? Because just take the irrational number. So suppose that you have extended. Okay, suppose you have get a continuous function from r to r. Okay, which extends this function continuously, right? So, but this will agree on q with this function. Let me denote the extension by f again. Okay, so then just take the number of irrational numbers, sequence of rational numbers, which converts to root 2, right? Then the functional sequence fxn tends to infinity, right? Because the functional sequence is xn minus root 2. This tends to infinity. So the limit does not exist. If the limit does not exist, then how can you extend it continuously?
Okay, sir, I got it. Thank you.
Yeah, but the that question might be interesting. Okay, so some of you told their answer, right? That okay, so now think about a uniformly continuous. Can a uniformly continuous function can be extended? You may think at home, okay, students. Suppose you have, this is not uniformly continuous. Suppose you have uniformly continuous function. Then can you extend it? Try to think about that. Okay, so right. Any other questions among these questions?
Hello, sir.
Yeah.
Sir, I just want to say thank you. Your teaching style is wonderful and we enjoyed the session and really learned many things. Thank you so much.
Okay, welcome.
Okay, thank you. Any others? So Lalit, so let us.
Sir, am I audible?
Yes.
Yeah.
Sir, yesterday you asked a question about local rings. Can you do that?
Yeah.
The
yes, I
Q
asked.
mod Z and
yeah,
Q mod
between
Z
Q and Z.
Yeah.
I mean, can you find some local ring which lies between Q and Z? That was the question, right? So
yes,
did you
sir.
find the answer? I would happy to listen from you.
No, sir, I didn't get it. So yes.
Okay, so you want to know about the answer? Okay, let me tell you. Okay, so
yes.
that's good question. So okay, if you could not solve some questions what I given, then you can ask me. Okay, so let me tell you that you want to find a subring which is local. Okay, so what do you want? You want some subring of Q, say m by n. It must have a set of all non-units should form a ideal here. once a set of all non-unit forms are ideal, then this becomes a unique maximal ideal, okay, in the ring S. So see, pick and fix a prime P, okay, fix and P does not divides M, N, and M comma N in Z, okay. So what is the example? M by N, where you have fixed a prime P, where P is not, will never divide the denominator. Okay, can you see it written? I have written here. I think it's not appeared yet. It's not visible to, I think, visible to you. Is it visible? What I have written here in the screen?
No, sir, no. It's not updated.
So you can listen me, right? I'm audible, but I don't know why. Yeah, now it's visible. So can you see this?
Yes.
Okay,
Yes,
so
yes.
let me know what are the units of this ring. So just try to think, what are the units of this ring? Okay, so how will you prove this, that this is an example of that type of thing? Okay, so you just show that what are the units C, then collect all the non-unit elements and see that that forms a ideal, and then that would be unique maximal ideal. Okay, so that is the answer to that question. So there are, I have given you infinitely many subrings, not only one, because once you fix a prime, you get one. Okay. Is it okay? That answers your question, right? So, okay. So anyone else want to ask something, want to comment, want to give suggestions, anything?
Yeah.
Okay, so I think we should stop here then. Yeah. So I should, I think, stop the recording, right?
Okay, okay. Thank you, Lalit, for today's session. Okay, let us, yeah, we can meet tomorrow at the same time.
Yeah, we will meet tomorrow at 8:30 p.m. Okay, and we'll be discussing the previous year problems. Then keep in mind that there will be a mock test on 5. Okay, on the 5th day. So I will let you know how to attend that, by the way, by the day after tomorrow. Yeah, let me stop the recording.
Okay.